Subtopic 1.2 Collision Theory. The learning outcomes for this video are: A. Explain collision theory. B. Define activation energy. C. Explain transition state theory. D. Draw energy profile diagram of a reaction.
For a reaction to occur, the molecules of reactants must meet one another. Because in gaseous and liquid states, molecules travel quite fast, they actually collide with one another. This simple view is the basis for the collision theory of a chemical reaction. Let us consider a molecule of reactant A mixing with molecules of reactant B in the gaseous or liquid state. As all the molecules are in constant motion, they collide with one another. Assume that in 1 second, the molecule of A collides successively with 5 molecules of B. If 2 molecules of A are present in the mixture, each of them collides with B 5 times. Therefore, the overall number of collisions doubles. Now, if we place 1 molecule of A among twice as many molecules of B as before, the concentration of B is doubled, and the number of collisions doubles too. We can see that the number of collisions, and consequently the reaction rate, is proportional to the concentration of each reactant.
Activation energy. Activation energy can be defined as the minimum energy required to initiate the chemical reaction.
Consider the general case of the decomposition of a compound AB to A2 and B2 molecules. 2 AB molecules must collide to yield the products. The collision of 2 molecules is different from the collision of 2 billiard balls. Molecules are not hard, springy objects with a definite, sharp outer boundary. The electron cloud of a molecule is diffuse and fuzzy. When 2 molecules approach each other, their electron clouds come into contact and repel mutually due to their negative charge. The closer they come to each other, the stronger the repulsion. Reaction can occur only when the electron clouds of molecules penetrate each other to such an extent that the formation of a new bond is feasible. This means that they must possess the minimum kinetic energy needed to overcome their intermolecular repulsion. Otherwise, the repulsive forces make the molecules simply bounce off each other and fly apart again without reacting. The reaction takes place only when the molecules are oriented in such a way that atom A can react with atom A and atom B with atom B. For example, when A meets B and B meets A, the reaction yields unchanged reactants and no net reaction is observed. Any other orientation will result in ineffective bouncing off of the molecules. During collision, the kinetic energy of 2 approaching molecules is converted to the potential energy of the resulting transitory combination of atoms, which is called the activated complex. The minimum energy necessary to form the activated complex is called the activation energy. The course of the reaction can be shown on a potential energy diagram. The horizontal axis is called the reaction coordinate. It represents the progression from the reactants through the activated complex to the reaction products. As the 2 AB molecules approach each other, their potential energy increases until it reaches a maximum when the activated complex is formed. The potential energy increase up to this point represents the activation energy for this reaction. As the reaction proceeds, the activated complex breaks apart to yield product molecules, and energy is released. When the potential energy of the products is lower than that of the reactants, heat is evolved, and the reaction is exothermic. When the potential energy of the products is higher, heat is consumed, and the reaction is endothermic. The shape of the curve in the potential energy diagram indicates that in every reaction there is a kind of energy barrier which must be overcome if the reaction is to proceed. Note that the activated complex does not always break apart to form products. The reaction can also proceed back to the reactants along the potential energy curve. This means that even if the orientation and minimum energy requirements are fulfilled, some collisions may still be ineffective.
Transition state is the configuration of the atoms of the colliding species at the time of the collision. Activated complex is the species formed at transition state. Characteristic activated complex. Activated complex is very unstable. Its potential energy is greater than reactants or products. The activated complex and the reactants are in chemical equilibrium. It can decompose to form products or reactants. On the screen right now are the energy profile diagram for endothermic and exothermic reaction.